All right, so we were in the process of converting 2011 to base 7, right? And so we divided 2011 by 7, and we got 287 with a remainder of 2, which tells us that we can make 2011 into 287 groups of 2 with 2 left over. So that tells us that the units digit is going to be 2, right? Because every time we have a group of 7, then we keep track of it in the next place value. All right. So let's figure out what the next place value is, what the next digit is. Okay, so we have 287 groups of 7. So let's figure out how many 7 sevens we have, or how many 49s we have. Okay, because the next one is going to be the 49s place. Okay, so if you figure out how many 49s we have, so if you just divide this by, this is the group of 7, if we divide by 7 again, we'll get the number of 49s. And the remainder will be what is in the 7's place. Okay, so if we take 287 and divide it by 7, then this is just 4, 28, and it divides evenly, 41 with a remainder of 0. Okay, so that tells us that we can group 287 into 41 groups of 7, but 287 are the number of groups of 7. Okay, so this is 7. This is the number of the groups of 7 sevens. All right, this is the groups of 7. All right, so this is a group of 7 sevens. All right, so we'll have 41 groups of 7 sevens, and then with nothing left over. So this will be the place value here. All right, so then let's take 41 and divide it by 7, and that just gives us 5 with a remainder of 6. All right, so we'll have 5 groups of 7 49s, 7 7 sevens. So this is the number of how many 7 49s we have. Groups of, yeah. So so this is the number of groups of 49s. Okay, so if we group those 49s by 7s, then this is 7 cubed essentially. So this will be the 343's place, and then we have 6 left over. Okay, so this is this place value here. This is the number of 49s. Okay. And then finally, we already really know that this is the 343's. That's how many 343's we have, and this is the number of 49's. Okay. Because we had the number of 49's was 41, right? But 41's not a digit, so we want to divide by 7 again. And so we have 6 49's and then 5 groups of 7 49's, okay, which is 343. All right, so what does that tell us our digit is? Okay, so we have 5 in the 343's place, we have 6 in the 49's place, we have 0 in the 7's place, and we have 2 in the 1's place. But you notice that doesn't match the number we had before. But that's because I've made a translation here, okay? Now, the numbers that we can use are 0, 1, 2, not 4, not 3, not 4. We can use 5, we can use 6, not 7, and we can use 9. But when I converted this to base 7, when I converted this to base 7, I just used the normal digits. So I used the digits 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, and 6. Did I miss something here? 0, 1, 2. What did I leave out? 1, 2, not 3, not 4, 5, 6. Oh, I've left out the 8. That's the problem. Alright. Alright, so let's put the 8 in here. Alright. 8 and 9. Okay. So I'm using these symbols. I can use these symbols to form numbers according to the problem, because I can't use 3 and 4 and 7 because you can't turn them upside down and get another digit. But when I converted this to base 7, I just used 0 through 6, just like I normally would. Okay, so you can see 0 is a 0, 1 is a 1, 2 is a 2, but here 3 is actually 5, 4 is 6, 5 is 8, and 6 is 9. Okay, so the 5 corresponds to an 8 as far as the symbol goes, and a 6 corresponds to a 9, a 0 corresponds to a 0, and the 2 corresponds to a 2. So then you can see we do get the same number when we translate the digits. Okay, we just use different symbols is all. In base 7 we typically use 0 through 6 as the symbols for the 7 digits that we can use. But in the problem that we're working on, where we were using those 7-second numbers and turning them upside down, the only digits that were readable upside down are these: 1, 2, 5, 6, 8, 9. Okay, so I have to translate 3 into 5, 4 into 6, 5 into 8, and 6 into 9. All right. So both ways we get the answer, and I thought this is what really intrigued me about this problem is the way that it really makes you think about what counting and numbers are. They're just symbols, and we are so used to thinking of everything in base 10 that it's really foreign to us to think in counting in any other base using any other symbols. And so it really makes you think about what counting really is. So anyway, the answer is 8,902.